Good day to you. Today we want to have a look at the application of triangle law of forces that we discussed during the last video. This is one of the questions. A mass of 2 kilograms is supported by two cords which make angles 30 and 50 degrees with the vertical. Find the tensions in the cords. First and foremost, how do we know that this will be in line with triangle law of forces? Fine. A triangle has 3 sides. That means there must be there must be 3 forces. And of course, the chords, since we are dealing with 2 chords and we are dealing with tensions in the chords, that means the tensions in the chords already represent 2 forces, okay? Then the mass of the body itself, which will be converted to weight. Weight is a force, so that will be the third force. That is how we know that this will surely lead us to a triangle. How do we sketch a diagram for this kind of question? Fine. Since it's supported by 2 chords, let's say this is a ceiling where the chords are supported. So let's say one chord is this, another chord is this, then this is the body. So the tension will be acting upward. Let me call this one T1, T2. So the weight of this body, let me call it W, which will be mg. Okay, so that means since they said the chords make angle 30 and 50 with the vertical, that means at the point of attachment of the chord, let me draw a vertical line. So this angle here, let me call it 30 degrees because this is the angle between the chord and the vertical. Let me draw another vertical here. So this angle between this chord and this vertical, let me call it 50 degrees. So I have formed a diagram for this arrangement. Now, how do I now make out a triangle out of this? It's very simple. All I need to do now is, so this one will give me, since the mass is 2 kilograms, that will be 2 times 10, which is 20 Newton. 10 is the acceleration due to gravity. Okay? So the next thing is, how do I form a triangle from here? Alright. To form a triangle from here, this particle, which is the body itself, let me locate it with this red dot. Then this vertical weight is this 20 Newton. So let me extend it up. I just want to extend it up. Now, this one of these 2 tensions, let me indicate it. So I will draw, let me pick T1 or let me pick T2. So as you can see, let's say this is my T2. Let me put the arrow here. So now, to now form T1, I will come to the end of this T2 and draw another line that will be parallel to the direction of this T1. Since T1 goes this way, that means I will have to do something like this. Can you see? So if you look at this direction, it's facing the direction of what? T1. So this will now be my T1. So this 20 Newton here can now be put here. Yes. Because this is vertical already. So since the arrow is pointing down, this arrow will be pointing down. This will now be my 20 Newton. That means I don't need this one again. So I form a triangle. Then how do I locate the angles? It's very simple. The angle between T2 and the vertical is 50. And this is vertical, this is T2. So this angle will be 50. The angle between T1 and the vertical is 30. This is the vertical, this is T1. So this is the angle. Here will be 30. So definitely to know this angle will not be a problem. Sum of angles in the triangle is 180. 30 plus 50, 80. 80 out of 180, here will be 100. So this is what we are going to work with now. So, having gotten the triangle, this is where you now need your mathematical knowledge. We have all the three angles and we have one side, which is 20 Newton. I can use sine rule. T1 over sine 50, which is facing T1, is equal to 20 over sine 100, which is facing 20. Then from there, you cross multiply, T1 will be approximately 15.6 Newton. To get T2 also,